Hello, everyone. My name is Paul, and welcome to Crosstalk Live, Leviton Network Solutions webinar series. Today's topic is Next-Gen Networks, Migration Strategies for 25 and 40G base T, High-Power PoE, and High-Speed Wireless. Our roughly 50-minute presentation will cover migration strategies for data center networks with Cat8, cabling recommendations for PoE-enabled devices, enterprise wireless access points, and high-performance copper cabling systems for all types of applications. Our presenter today is Mark Deering, Senior Product Manager for Leviton's Copper Solutions. Mark manages Category 8 solutions in development, shielded systems, cable management products, power solutions, and software-managed solutions. He is a certified RCDD, actively participates in TIA committees, and has co-invented several patented products and design features. Mark, take it away.
Thank you, Paul, and thank you to our audience. What we're going to cover today is a brief look at the infrastructure trends. We're going to touch on some of the next generation copper standards that are driving the industry designs. And we're going to switch speeds a little bit and look at two of the applications that are really driving network design in the enterprise application, and that's PoE and wireless. And finally, we're going to wrap up with some ways that can help you design for some of these applications and touch on briefly some of the solutions that Leviton has to help you in your network migration. So the first thing we're going to talk about is infrastructure trends, and what are the technology drivers behind those trends. First and foremost, it's cloud services. Every day you hear about somebody else that's offering something on the cloud, and this general outsourcing of storage and processing has been one of the main drivers for small businesses. Just the ability to use services like Amazon Web Services, where they would formerly have to invest heavily in equipment and maintain it internally. Convergence is another driver. Everything is going IP, where it used to be just the voice and data, the computers and the telephones. Now you're seeing all of your building management systems, your security, your HVAC. Everything's getting connected to the web, to the internal network, and communicating. That drives more bandwidth and more needs for your infrastructure. Virtualization advancements. As you can put more and more virtual servers into your data center, that requires more bandwidth connections for the physical device that's housing those multiple virtual servers. So instead of perhaps a 1 gigabit connection, you now need to have a 10 gigabit or higher connection to support all of those virtual servers. Multi-gigabit base T switches, whether it's in the data center or whether it's in the enterprise, 1G is no longer sufficient to support the needs. So you're starting to see 10 gigabit and higher switches coming into the market. And of course, we've got different variations in architectures on how you deploy your switches, whether it's a top of rack or an end of row / middle of row topology. This is all going to have an impact on the choices you have to make in terms of your infrastructure. Let's look at a brief history of the speed migration. This chart shows cloud server deployment. When I think of cloud, I like to think of data center. A data center that is remotely located, not something on your direct premise. As you can see, going back 2008 all the way up until 2011, 1 gigabit was the dominant port in your data center and your cloud data center. But right around 2011, you started to see a shift where 10 gigabit became the dominant port speed. And that has continued today and is expected to continue until roughly 2019, where a variety of other port speeds are going to become prevalent in the cloud data center. One of the things I want to point out with this slide is this is talking about port speed. It's not talking about a specific media type. So when we talk about a 25 gig or a 40 gig port speed, it could be running over copper, it could be running over optical fiber, it could be running over twin axial cable. We're just talking about the speeds for the servers. Conversely, if we look at the premise server deployment, this could be ports that are in a telecom room or possibly in a locally housed data center, something that is on site. 1 gigabit is still the dominant port speed for your switches and servers. It was actually this year when it's expected to see 10 gigabit become the most dominant port speed. You can see right there in the middle of the green bar, about half of the ports that are being installed into the local data centers and telecom rooms are 10 gigabits. And that's going to become the dominant speed further out. Why is that? If we look at the server shipments, this chart is showing the number of ports that have been shipped for the enterprise or the premise data center. It's in the top bar shown in blue. And then you're also seeing the ports that have been shipped to the cloud data centers in green on the bottom. And over time, those have steadily been migrating towards the center. And 2018 is the current estimate for when you're going to see a convergence or a flip of those, where more ports are going to be installed in cloud services than in local on-site services. When you're installing a data center, they're very, very expensive. But we want to point out that even though the cabling system is only 3% of the overall budget, the decisions you make with your cabling system affect all of your IT investments. Your very, very expensive active gear is not going to operate at peak efficiency if the cabling system becomes the bottleneck. And that's the component that's driving the performance of your system. So what we want to make sure is that people understand the effects of their decisions downstream when they're choosing to install a specific category of cabling system. Let's look at some of the standards that have been driving the networks over the last 10 to 15 years. If we're looking at Ethernet, and this chart is showing specifically the base T standards, which govern the twisted pair copper cabling system, started in 1990 with 10 base T, what we think of as category 3. 5 years later, we went to Cat 5. 2000, we had Cat 5e at gigabit Ethernet. And that's also when we had Cat 6 shortly thereafter. The last major Ethernet speed that was released was in 2005, roughly, with Cat 6a. And as you can see, it was a very steady progress where when one Ethernet speed was finished, we replaced it with a faster Ethernet speed. But now we're in a converged area. It's taken 10 years, but now you're looking at 4 different speeds that have been introduced by IEEE and the cabling community. And one of the reasons for this is the different speeds are focused on different applications. The top 2, for category 8, 25 and 40 G base T, are meant to serve the data center application. The bottom 2, running over Cat 5e and Cat 6, are meant to serve the enterprise. We'll touch upon each of those a little bit further into our presentation. So for the last 5 to 10 years, cabling manufacturers have been talking to customers about the migration plan from 1G to 10G. How do we migrate from your Cat 5e or Cat 6 cabling to your Cat 6a cabling? And it's been a pretty straightforward discussion. Now we're talking about migrating from 10 gigabit up to 40 gigabit, going from a Cat 6a cable to perhaps a Cat 8 cable. And that was what the industry was focused on 3 to 4 years ago when they started looking at the next generation of copper cabling system. Migrating from 10 gig to 40 gig was a natural progress because that's what happened on the fiber, the optical fiber side. You had 10 gigabit fiber, then you jumped up to 40 gigabit. What the industry found while they were working on the specification development was that 40 gig really wasn't the best next step. It was a little bit too much speed, too much more expensive than what the industry needed. So they circled back and decided we're going to look at 25 gigabit as the next speed for the data center. But rather than having to define two different cabling types, the industry decided that we're going to use Category 8 for both 25G and 40G speed. Circling back on the premise side, we now have two different options for Cat 5e and Cat 6 cabling as well. The industry has developed specifications for 2.5 gig and 5 gig data rates designed to run over installed Category 5e and Category 6 cabling. And for many of our Europe markets, we're looking at the different classes as well, the ISO classes. So Cat 5e would be Class C, Cat 6 is E, 6A is Class EA, and then on and on. When we're talking about Category 8, first and foremost, remember that Category 8 is a data center solution. It was designed specifically for the data center to serve the need at the edge of the data center. But what we need to realize is that we introduced a different topology for Category 8. For many, many years, we've been talking about the 100-meter 4-connection channel that IEEE, TIA, and ISO have been promoting. With Category 8, we're talking about a 30-meter 2-connection channel, which can have a maximum of a 24-meter permanent link with up to 6 meters of patch cord on each end. This is critical to understanding your design layout, because if somebody has an existing Category 6A installation and they simply want to upgrade to Category 8, we need to take a close look at the design parameters to find out if it's going to work, or if we need to rearrange some of our cabinets. So within the data center, Category 8 is designed to support the switch-to-server links at the edge. It's compatible with either end-of-row or middle-of-row topologies, or you can use the top-of-rack topology. The switch-to-switch links going from the edge all the way back to the core are going to remain fiber. However, the assumption is if you're upgrading your edge networks to either 25 or 40 gigabit, most likely your core fiber data is going to have to upgrade as well to either 100 or perhaps 400 megabit. And there is new technology on the fiber side that's outside the scope of this webinar that you might want to look into. How did we get to a 30-meter permanent link for Category 8? During the course of the development, IEEE conducted a survey and found out that 80% of the links to the data center are 30 meters or less. So trying to balance the cost of the electronics, the cost of the cabling, the efficiency of trying to design the different systems, IEEE settled on this 80% rule and said 30 meters is going to be just fine. If you think about it, in a middle-of-row topology where you can run the cable on both sides of your switch and server racks, that can support up to 60 cabinets. It's quite a big, quite a long length of cabling that you can support in the data center. Leviton is a leader in the Category 8 solution. I want to say Leviton brand Rex. The Category 8 solution is a co-development. It's the first time that Leviton and brand Rex engineers have worked together to create an end-to-end solution. Leviton's expertise is on the connectivity side with the jacks and the patch cord plugs. And of course, brand Rex has had a long history of producing high-performance, high-quality cabling systems for the industry. We were the first in the industry to have third-party verification to a draft Category 8 system. We've got an end-to-end system building on multiple patented technologies found in the connectivity system. And it's the same form factor and termination style from 1G to 40G, built on our Atlas X1 jack platform. Let's look specifically at some of the connectivity options for Category 8. Keep in mind that with Category 8, there's two different types of options, specifically the Category 8.1 components, which are based on the RJ45 solution. This is a globally recognized and adopted platform, backwards compatible with existing copper cabling systems, PoE compatible. It's recognized by both IEC and the TIA standards, for those that adhere to some of the American standards, wherever you are in the world. With ISO IEC, it's called a Class 1 channel. The other option is Category 8.2 components, or a Class 2 channel. And these are non-RJ solutions. TIA did not recognize the Class 2 solution in their standard, although ISO does recognize it. And for many of you, you may recognize some of these connectors if you're familiar with the Category 7A or the Class FA solutions. One of the challenges with a Cat 8.2 solution is that the active gear is going to have an RJ45. And with the design limitations of the two connection channel, that means that you're going to have a hybrid patch cord, where the patch cord is going to have an RJ45 on one end, and it's going to have one of these non-RJ connections on the other end. Here's a quick chart that shows the Class 1 RJ45 solution compared to the Class 2 solutions. And you can see the IEC standards that talk about the various Category 7A interface, and you can also see how the different connectors vary compared to the RJ45. In the top right-hand corner, you can see that all 8 pins are across the top, side by side on the RJ45, whereas with these Class 2 solutions, they take the pairs of pins and they push them out to the 4 quadrants, to the 4 corners. And that's one of the reasons that they can achieve the electrical performance required for a Category 8 or Category 8.2 solution. Leviton believes that 8.1 is the best choice for Category 8. That's one of the reasons why we chose to maintain the RJ45 interface on our solution. Some of the advantages is that it's a single connector, regardless of where you're at. It's got the RJ45 port, same as the active equipment. It's compatible with end of row, middle of row, but also top of rack architectures. And by that I mean, with a top of rack architecture, you're using essentially a patch cord that's going to connect the switch directly to the server. If both of those active pieces of equipment are using an RJ45, that by definition that eliminates a Class 2 patch cord from being able to be used. And then you've also got the ability of backwards compatibility with the lower data rates because of the RJ45. So we talked a lot about Category 8 and the base T solution. Let's look at some of the alternatives that people would consider for 25 and 40G based various DR connecting hardware, so the other data rates. One of them is the twin axial direct attach cable. These are the direct switch to server connections used in a top of rack architecture. One of the disadvantages of this is that it's a single speed. It doesn't allow for auto negotiation. And auto negotiation, for those that aren't familiar, is the ability for two pieces of active equipment to have a handshake or have a conversation and settle on a data rate that works for both of them. That means a 25G base T switch can also support a 10G base T server, whereas with the twin axial or the optical fiber, that port speed is going to be fixed. It's either 10G, 25G, 40G. It's not going to be able to talk a different speed. The SFP Plus format for the 25G has a distance limitation of 5 meters, whereas the 40G, the QSFP Plus, would be limited to 7 meters. And this is really not much of a design constraint. If you think about the direct attached cables and the top of rack topology, really are meant for connections either within the same cabinet or between adjacent cabinets. The other media type that you can use for 25 and 40G is optical fiber. You can have direct attached cables using multimode optical fiber. You can see the orange cable in the bottom of the screen. But you can also use structured cabling using either duplex LC or MTP, some people call it MPO connections. As with the twin axial cable, there's no support for auto negotiation with optical fiber. What we know is that the fiber transceivers can make this the most costly option. However, it's got the furthest reach. You can get up to 100 meters in the structured cabling approach using optical fiber, multimode optical fiber. This is going to be the only option that you can use for speeds of 25G or higher if you need to go beyond the 30-meter channel. Let's look at Category 8 top-of-rack advantages. Compared to the direct attached cabling using twin axial, you're limited to 25G 5 meters, 40G 7 meters. We believe Cat 8 is going to be a lower cost alternative. Some of these direct attached cables with the SFP type of interfaces, they can be quite expensive, whereas with Category 8, it's basically a patch cord. It's the same advantage that Category 6A has had compared to the 10G SFP type of cable. In the end of row, middle of row advantages, you're really looking at OM3, OM4 fiber. Cat 8 is going to be the lower cost alternative for channels less than 30 meters. Talked about the advantage of auto negotiation, backwards compatibility. This provides mixed data rates on the same switch. One of the key advantages of this is the ability to stagger your upgrade migration. If you're going to upgrade your data rates using twin axial or the optical fiber, it's what I like to call a rip and replace. You have to replace everything at once. But with Category 8 and a base T solution, you can upgrade your switches now to 25G base T. Those same switches will use auto negotiation and support 1G and 10G ports now with the ability to upgrade to 25 or 40G at some point in the future as your budget or as your project migration allows. But finally, I'd like to remind everybody that we've been talking about Category 8 for many, many years. All of the standards are finally complete. IEEE published 802.3BQ last year. TIA at the bottom had 3 relevant standards for Category 8. All of those were published. And with ISO, the 11801-1 standard, it is in its final draft, which means it is technically complete. Only final editorial changes are being accomplished. We expect that to be fully published by the end of this year, possibly in the October-November timeframe. There's several things we want to talk about today relevant to the enterprise. We're going to start with PoE, or Power over Ethernet. This is something that's been evolving since the first standard for Power over Ethernet was introduced in 2003. That's when we had the ability to transmit up to 15 watts of power or have roughly 13 watts of power delivered to the end device. They call this Type 1 PoE. In 2009, IEEE introduced the AT version of 802.3. Sometimes people called this PoE+. And the reason is because it roughly doubled the power that was able to be sent, and then roughly 25 watts of power delivered at the device. This was called Type 2 PoE. Since 2009, several new devices have hit the market requiring more and more power, which has caused the industry to have to adapt. Why is PoE usage on the rise? Well, there's this Internet of Everything. We talked at the very beginning about the technology trend of convergence. As more and more devices turn towards Ethernet for communication and use the base T category cabling for their data communication, it makes sense to be able to power them using PoE. One of the reasons for the rise of PoE is the RJ45 compatibility. It's a universal connection type for both communication and power interface. It's an economical, easy way to back up your devices with a centralized power solution. Many of our data centers, many of our telecom rooms either have some sort of a UPS or they're tied into a backup generator. So it makes sense if you're going to have your data network backed up, why not extend that power capability out into the premise for your wireless access points, your security cameras, anything that's critical to your network. So it's very efficient to be able to provide backup power from a central location instead of having to rely on your entire power grid being backed up. PoE is a major driver of copper cabling growth. We have a lot of conversations within the industry with the rise of optical fiber. It's going to be the death of copper cabling system. Well, we're finding out that copper is doing just fine, primarily because of the ability to support high bandwidth applications and drive power at the same time. So if we look at the standards over time, we talked about the Type 1 PoE in 2002, 2003. That's your 15 watts of PoE. Most of the applications were your early generation access point, some access control, and then some what we call the thin client devices, things that didn't require a tremendous amount of processing power or perhaps not even a screen. In 2009, with 802.3 AT, you had 30 watts of power. The application that was primarily deriving the need for PoE Plus were cameras, specifically your pan, tilt, zoom IP cameras, where not only did you need to power the active electronics for the camera, but you needed to power the motors so that you could have that mechanical control over the direction. Then you also saw some video phones, some alarm systems, and some readers for the security system. But the industry didn't wait. There were other applications that were driving the need for even more power. One of them I want to call out specifically is those pan, tilt, zoom cameras that were located outside. Because they were exterior, they needed to have some sort of a heater inside of them to make sure that the lens and any type of glass on the front didn't fog up. It's not a very good camera if your vision is obscured. So Cisco ended up developing this new type of proprietary powering standard. They called it UPoE, that provided up to 60 watts using all four pairs. And then finally, we've got a new technology that is just starting to really become mainstream called HD-based-T. This is primarily supporting video, high-speed, high-definition video for either conferencing or televisions or possibly even powering a full desktop solution. The difference here is that HD-based-T uses up to 100 watts of power. Recognizing the need for these high-power applications, IEEE has begun developing new standards, extending the standards for PoE to be able to support 60 watts and 100 watts. and they call that 802.3 BT. So there's several things that are different about the BT standard compared to the previous ones. First and foremost, this is going to be the first true PoE solution that uses all 4 pairs, all 8 conductors to deliver power. This is going to increase your system efficiencies, but it also offers a little bit of higher complexity. It introduces type 3 and 4 power variants. You're going to hear a lot about 100 watt PoE as the maximum that you want your cabling system to be able to support. But one of the things that is often overlooked, but I think is going to be one of the most powerful advantages of the BT PoE standard, is for the first time you're going to be able to support 10 gigabits along with power on the same cabling. Any of your PoE switches or your PoE midspans that you find in the market today, the maximum data rate that they can support is 1 gigabit. So that means if you have a device, say a wireless access point, that you want to have the ability to have 10 gigabit bandwidth, but you also want to power it over PoE, the only choice you have today is to run 2 different cables to the access point. So when 802.3 BT compliant active gear becomes available, you're not going to be able to use 1 cable to support your power and your bandwidth needs. I think that's a very significant advantage that we're going to see in the next several years. One caution, however, with power becomes heat. So the standards bodies, both TIA and ISO, and a lot of the cabling manufacturers have been spending a lot of time investigating when you start to run power over the cabling system, how does that impact from a safety, from a design standpoint? And what we have found is the more that you bundle the cables together, the more the cable at the center can heat up. And so TSP 184A, published by TIA, it provides guidance regarding the maximum bundle sizes to limit the temperature rise to 15 degrees Celsius. And where we got the 15 degrees is the average ambient temperature is assumed to be 45 degrees C, and most cable jackets are rated to 60 C. So the idea is that if you're going to run power through your cabling system, you want to design it so that it's not going to exceed the cable jacket temperature rating. Through the course of this investigation, we found that cables behave differently in conduit versus air. So several things that need to be considered when you're designing network PoE capabilities are: what is the anticipated ambient temperature? What's the cable jacket rate? Is it actually 60 degrees? Is it 75 degrees? Is it something different? What's your wire gauge and cable construction? The larger the wire gauge, 23 gauge is going to perform better than 24 gauge because it's a larger size. What's your cable construction? It's been discovered that shielded cabling with the foil around the outer jacket or foil around the pairs can perform better than unshielded cabling when you're talking about heat dissipation. For the Europe markets, ISO IEC has technical standard 29125 that's coming out. It's going to be harmonized with the data with TSP 184. ISO and TIA work very closely together. And the document's in the last round of edits and is expected to publish later this year. So anybody who is designing networks and they're anticipating running power over Ethernet over the copper cabling system, I highly recommend you take a look at one of these 2 documents to get some guidelines so that you're heading down the correct path when you're designing your system. The other thing you want to consider is when you're choosing a connector, what is the PoE rating? And one of the things that a lot of the manufacturers have been publishing lately is their maximum PoE ratings. For Leviton connectivity, our Cat 6A components and Cat 6 components are all rated up to 100 watts PoE, whereas our Cat 5e components are rated to 60 watts PoE. And one of the reasons why Cat 5e tends to be rated a little bit lower is because the majority of the Cat 5e cables have a smaller conductor size. So it's going to perform a little bit worse in terms of heat dissipation. Another thing to consider with PoE is this concept of a powered disconnect. So if anyone's not familiar with how PoE works, part of the IEEE standard for PoE requires that the powered source, the PoE switch for example, it's not allowed to pass power through the cabling until it has had a conversation or a handshake with the device to confirm not only, yes, I am a PoE device, but what type of PoE can I handle? So if the device says that I'm only a type 2 PoE, then the maximum amount of power that the source is going to provide is 30 watts. So there's quite a bit of communication that goes on in that short time span when a powered device is first connected. The problem is when you take the patch cord and you disconnect it, there's no way to have that conversation because the source and the device don't know when they're going to be disconnected. So every time you remove a patch cord from a PoE device, it's going to be a disconnect under load. The problem that you can run into is over time, you can have some sparks that could occur, some arcing, and that could damage the tines and the spades on the patch cord plug. So one of the advantages that we have with our Atlas X1 connector with the RFT, tension force technology, is the tine geometry is such, and you can see a large picture in the bottom right-hand corner. The tine is designed so that any damage or arcing occurs at a different location from where the data is going to be passed. So as you can see, there's a little area right around the middle of the tine with some red lettering, so the damaged area from arcing. That is the location where the spade finally disconnects from the tine. Whereas further towards the left, you can see there's a location that looks in white. That's where the tine and the patch cord are connected when all of the data is going to be passed through. So that's an important thing that you want to evaluate. If you're going to be installing connectivity and cabling systems for high power PoE, whether it's 60 watts or 100 watts, you want to make sure that you're going to be choosing a solution that is going to hold up over time when somebody's going to be disconnecting and reconnecting under load. One of the other things that you might want to consider, especially if you're using an unshielded solution, is what kind of heat is generated and how is the jack able to dissipate the heat under PoE load? And what we have found with our Atlas X1 unshielded connector, because we use a metal body, we found that the metal body has a 53% improvement over heat dissipation over plastic connectors. You can see a simulation that our engineers have run showing the thermal buildup on the Atlas X1 connector on the left and the typical plastic connector on the right. So this is the industry's only solid metal body unshielded jack. So it's just another consideration that you want to put in front of yourself when you're making selections for networks that are going to be supporting high power PoE. So all of this, a lot of things going on in the network, a lot of things going on with the high power PoE, but when we start talking about the various applications that are going to be remotely powered, a lot of them are going to be high bandwidth applications. So wireless access points, your HD TVs, kiosks, various IP cameras, they're going to require high bandwidth, they're going to require high power PoE, and all of this is driving the selection of Category 6A cabling. So the advantages of Cat 6A for PoE networks: they use 23 gauge copper conductors, which provides the better heat dissipation compared to lower categories. Less energy lost to heat means more power reaches the device, which in turn means more efficient power utilization. So the more efficient you are with running your power systems, the more money you save. A second aspect is the less heat that's generated means that there's less energy you're going to have to spend to cool, which translates into reduced operating expense. And the other thing is that it avoids cable derating for the longer cable runs. By operating cooler, you're going to be able to have the longer length without compromising performance. Many people don't realize the 100-meter channels that are specified in both ISO and TIA, they assume a 20-degree C ambient temperature. As the temperature of the cable increases, you may have to reduce that overall length in order to make sure that you're achieving the electrical performance for the specific category rates. So Category 6A cabling offers the best solution for enterprises seeking the system longevity, the faster data rates, and the support for high power PoE. Just a quick recap of the relevant standards. We talked about IEEE 802.3 BT for the 4-power PoE that introduces the types 3 and 4 up to 100 watts. Current estimates are that it's going to be early 2018 when that gets published. ISO's TS 29125, I'm anticipating that to be published any time now. Probably, if not June, it might spill over into July. But that should be on the market very, very soon. And TIA's TSV 184 is already published. I'd like to turn our attention now to the second application, which is wireless. So if we look at the history of wireless, jumping all the way starting in 1997, 2013 was a very significant year because with the release of 802.11ac Wave 1, for the first time we've been able to transmit data wirelessly faster than what you could get over a Category 6 cable. So that was a pretty significant milestone. And then a couple years ago with Wave 2, you're now looking at 6.93 gigabits. Quite a bit of increase in bandwidth over the years. And if you're curious about what does that mean for the different standards, here's a chart that shows for 5 gigabits of download, how long is it going to take for those various data rates? So with the G access point, 13 minutes. Upgrade to 802.11n, it drops it to 1 minute. AC Wave 1, it's 33 seconds. With AC Wave 2, you can download 5 gigabits in 6 seconds. That's one of the reasons why people are migrating towards the faster speed. And not only are we looking at 6.9 gigabits, the next generation, 802.11ax, is in development. We expect it to appear sometime in 2019. That's going to have a 10 gigabit data rate. So the last topic we want to talk about is 2.5 and 5 gigabits. And one of the reasons why people are looking at various ways to extend their wireless network is the wireless bandwidth is simply exploding. The bring your own device to work type of thing. Many people have multiple wireless devices, whether it's multiple phones, a tablet, a laptop, many devices that are trying to utilize that wireless network for data rates. The estimate is by 2019, the global IP traffic is going to pass 2 zettabytes annually. If you're not familiar with that term, that's a zettabyte is a 1 followed by 21 zeros. It's a lot of data, and that's just driving more and more traffic on our network. So one of the biggest challenges you have with the installed Category 5E and Cat 6 cabling system is it's limited to 1 gigabit. And in orange, you can see a 1 gigabit switch using Cat5e or Cat6 cabling connected to an access point. The problem is when you have multiple devices connecting to that access point, trying to use that data, you've taken 1 gigabit and you're spreading it out among all those various devices. So your physical connection between your access point and your switch can quickly become the limiting factor or the bottleneck. So what we're trying to do, the active equipment manufacturers are trying to utilize the installed cabling more efficiently. So if you hear of a term called N-base-T, switch manufacturers are introducing products that can support 2.5 gig or 5 gig on their switch ports. And by doing that, they're increasing that pipe for data between the switch and the access point. And that means the access point has either 2.5 or 5 gigabits of bandwidth that it can spread out between the various devices that are trying to connect to it. That's the ultimate goal of the 2.5 and 5 gig. Now, there are some concerns that you need to be aware of. One of the biggest challenges with trying to use 2.5 or 5G is the fact that they're operating at higher frequencies. Category 6 was designed to operate at 250 megahertz. Category 5E was designed at 100 megahertz. None of those were really designed to mitigate the alien crosstalk the way Category 6A was. And if you're not familiar with alien crosstalk, that's the phenomenon where energy from an outside cable, one of the ones labeled with the D in the picture, is crossing over to another cable and disturbing something that's what we call the victim cable. Now, the energy and the crosstalk within a cable is able to be eliminated by the active gear because they've got signal processing within the port. When you're talking about alien crosstalk going from cable to cable, the active gear doesn't really have a way of eliminating that, so they rely on the cabling system. So the other things that we need to be concerned about is the cable bundles with the mixed speeds. Tests have shown that if you have a cable of 10, and some of them are running at 10G, some are running at 1G, some might be running at 5G, that can perform a little bit worse than if you had all of those running at the same data rate. Then the other concern is that 802.11 AC Wave 2 has the data rate of 6.9 gig. We talked about the AX standard that's going to be supporting up to 10 gigabits. These are well in advance of the 5 gig max that you're going to be able to use over the Cat6. So the takeaway here is that if you're going to pull any new cabling system, Category 6A offers the best solution. So you're future-proofing it. You're making sure that you're going to be able to operate these higher bandwidth access points over the next 5 to 10 years. It also provides the advantages of the power delivery that we talked about previously. So from a standard standpoint for 2.5 and 5G, IEEE has published. ISO has a document, the 11801-9904, that's expected to publish in Q3, which provides some guidance on how to mitigate installed Category 5E and 6. And then TIA has published TSP 5021, which provides some guidance. So my final topic here is just some design considerations when you're planning for your wireless access points. One of the things, there's a couple of standards that you can turn to. TIA has a document called 4966, Infrastructure for Education Buildings, and there's a chart that you can look at that compares how many people you're going to have in a building versus how many access points you think you might need for covering them. Just a rule of thumb here, but it does provide a little bit of guidance if you're trying to design, how many do I need to install in order to make sure that I've got adequate coverage. ISO has a document, TR 24704 that talks about how to place your access points to ensure maximum coverage. And in this case, they're talking about tight-fitting hexagonal cells where you have a 12-meter radius circle, and you put those all together so that you can make sure that even though there is a little bit of overlap, all of the areas will have coverage. While this technically is the most efficient design method, I prefer the TIA recommendation with TSV 162 because it's a grid approach, and I think it's easier to overlay the grid onto a building. And in this case, they recommend a 60-foot by 60-foot grid, or 18.3 square meters. And then the recommendation is to put 2 equipment outlets right in the center, and then you can have patch cords up to 13 meters in length. One caution when you're designing for the access points, because the patch cord connecting to the access point tends to be a little bit longer, you've got to make sure that you don't exceed the 100-meter channel total. So in this case, if you used a 13-meter patch cord, the maximum permanent link you can have between the telecom panel and the equipment outlet is 80 meters. So we just want to be careful that you don't exceed the design specification. And then finally, frequently we get the question of why 2 equipment outlets? Well, it's for future proofing. We talked before about the fact that currently you can only have power over Ethernet with 1 gigabit. So in the case of the top grid there, you may have to run 2 cables to be able to get 10 gig of data rates, with also having a second cable for PoE. In a conference room, you may need to have 2 access points to cover the density of people. Or you may just want to have 2 access points in case you're going to change from an office to a conference room, or if you're going to upgrade from, say, an AC to an AX, you may have to have 2 access points to handle that same amount of area for the coverage. Leviton offers a couple of products that you can use to assist, especially if you're having a connection that's above a raised ceiling. We've got an in-ceiling bracket that you can put either a surface mount box or the jack directly into it. And that provides a convenient place for the end of the testable permanent link, which you can then put a patch cord on, and then you can see in the photo there the access point is just directly mounted below the ceiling tile. So to summarize, we talked a lot about the different topics, but the takeaways are 2.5, 5, 25G, and 40G are the emerging options for your base T connectivity. Category 8 supports both 25 and 40G base T in the data center, and it offers several advantages over the optical fiber and twin-ax. Reminder that 2.5 and 5G base T are targeted to support the wireless transmission over the installed Cat5e and Cat6 cabling. It's not designed for newly pulled or newly installed Cat6 cabling. But overall, for reasons of bandwidth and for reasons of power delivery, we strongly recommend Category 6A or Class EA is the recommended cabling for new installations anytime you have to pull a new cable. And just a reminder that Leviton offers innovative solutions to support your current and your infrastructure needs.
Very good. Thanks, Mark. We do have let's squeeze in at least one question here. We're short on time, but one of the questions that we have is understanding that Cat 8 standards have now been ratified. I don't see any Cat 8 products in the market. When can we expect to see Cat 8 products in the market?
Very soon. You're going to start to see the cabling solutions become available first. I know that there are a couple of individual component products that have been published and released, individual jacks and plugs. To date, I'm not aware of any end-to-end cabling solution, but I would expect that July, August, you'll start to see ones hit the market. The active gear is going to take a little bit longer. I was hoping that we would start to see some active equipment available by mid-2017. I think it's probably going to be closer to the end of this year or early 2018. And one of the reasons I believe is because the active gear manufacturers, the switch people such as Cisco, Arista, and people like that, have been focused a little bit more on the 2.5 and 5G equipment. And they're going to be following up a little bit later with the 25G equipment.
Very good. Thanks, Mark. It looks like we're out of time, and so this will conclude our presentation. Thanks again, and have a great rest of your day.